Welcome to Analyze It. In this video, we are going to talk about partitioning a dataset with an optimum number of clusters. We will see how to determine the optimum number of clusters with K-Mearn using machine learning. Specifically, we will talk about Inertia, the elbow method, and how to compute the optimum number of clusters and run K-Mearn in Python. First, let's see what K-Mearn does. K-Mearn is basically an unsupervised machine learning algorithm that identifies subgroups in your dataset. With K-Mearn, you can find homogeneous subgroups within your dataset such that data points in each cluster are as similar as possible according to a similarity measurement such as the Euclidean base distance. For example, with this two-dimensional dataset, I plotted a scatter plot and I wanted to group this dataset or this data point in two groups. So I run a K-Mearn and I end up with this grouping such that all points in the blue are in the same cluster, cluster 0, and all points in orange are in the same cluster. So this is the purpose of K-Mearn. Certainly you can choose the number of the cluster that you want. In that case, I choose 2, but you can choose 3, 4, 5, 6, whatever the number you want, based on your knowledge on the data set. But there's a question that often came out is, is there an optimum number of clusters that you can use to run your K-Mearn? Absolutely yes, the response is. And there is an optimum number of clusters that will be better for your grouping. To calculate the optimum number of clusters, we need to introduce the inertia measurement and see what it does. Inertia measures how coherent the different clusters are. It is calculated by measuring the distance between each data point and its centroid, then squaring this distance and summing these squares across one cluster. Let's continue with our two-dimensional dataset. So what the inertia will do for you, it will first set the center or the centroid of a cluster. In that case, I start with the blue one, and then for each point in my cluster, it would calculate the distance and then square it. And it will sum the distance for all my cluster, all my points in that blue cluster. And then when it's done with the blue cluster, it will go to the orange cluster. We'll take the distance, which is the distance for each point in my cluster in respective to its center, and square it and do the sum for all my points in the orange cluster. And then when it finishes with all the clusters, it will basically sum it. Now that you have a good understanding on how to calculate the inertia for a specific number of clusters, let's see how you can use inertia to find the optimum number of clusters. First of all, what you need to know is that a good model is one with low inertia and a low number of clusters, K. However, this is a trade-off because as K increases, inertia decreases. So a good method to find the optimum number of clusters is the elbow one. And this method basically computes the inertia for different K. Then you will make a graph to find the point where the decrease in inertia begins to slow. For example, you can see here, I compute the inertia for 7 number of clusters. In the first cluster here, you see the inertia is really high, something between 600 and 700. When I run the inertia for 2 clusters, it has dropped to something a little bit between 255 or 250. But when I arrive at number of cluster 3, it has decreased, but when I continue for 4 or 5, there is not so much reduction that has been added to my inertia at cluster number 3. So we can decide that 3 clusters is the optimum number of cluster that I need to use when running the K-Mearn. One rule of thumb is also to look where the level of cluster and the inertia are showing somehow a linear trend. For example, we can see here there is a linear trend. So we'll start looking at the cluster where this linear trend started. Here we don't have a linear trend. It's kind of a curve. So I will be using this point, which is basically the elbow. Now that you have a good understanding of the purpose of K-means, and you know or you understand what is inertia and how you can use inertia to calculate the optimum number of cluster, let's do a practical exercise in Python using a dataset. And I will do this exercise using the IDE, one of the most popular IDE in Python, which is Jupyter Notebook. Let's jump to my Jupyter Notebook and start doing all of this fun work. Okay, I open my Jupyter Notebook, which is the IDE that I'm going to be using to type my code in Python. So through this exercise, we're going to do 7 things. The first thing that we'll be doing is that we're going to import the necessary libraries. Then we'll see how to load, view the dataset, and as well as dropping the rows that have empty value. Then we will be selecting the features and converting them into Numpy array. The feature are the variable that I would want to use to run my K-Mearn. Then we will compute the inertia for each of the number of cluster using the loop function in Python. And we will be printing the inertia value and locate the elbow point. And we will run the K-Mearn with the optimum number of K and assign each row of the data frame to a cluster. And finally, the fun part is to visualize the clusters. Okay, I need to import 5 libraries. The first one that I need to import, and I'm going to import, is Panda as PD. Panda is a library that that allow you to play with data frame, transform, and do all of the work in the data frame. Then the second one is Seaborn, which is a visualization library. So I will import Seaborn as SNS. The third one is the Numpy. Numpy is a library that allows you to work with array. So I will import it. Import Numpy as NP. The second visualization library that I will import is Matplotlib. Remember, we imported Seaborn, but Seaborn is built upon Matplotlib, and often they both together they work for visualization. So I will say import matplotlib.pyplot as plt, and the most most important one is scikit-learn, which is a machine learning library. So from scikit-learn, we will import the cluster and the K-Mearn unsupervised machine learning. So we'll say from SKlearn dot cluster. I'm import cluster, and from cluster I will import K-Mearn. Import K-Means, and I will shift and press the shift and enter on my keyboard to run these cells of code. Okay. The second thing that I want to do actually is to have a data set to do my clustering. So, you know, Seaborn has a bunch of example of data set. So I will import one that is called Penguin. So let me import the Seaborn Penguin data set. So I will call it df equal SNS dot load. So I will load underscore data set parenthesis and type the name of my data set, or of the data set that Seaborn has created. And Seaborn has created a bunch of data sets, so I'll be using the Penguin one. So I will be Penguins. All right. And also one thing that I don't want, I don't want my data set to have empty value, or what they call the non-value. So I will have to drop all the row or the columns where I have empty value. So what I will do, I will basically do the same, and because my data set is df, I say df equal df drop na and axis equal 0. Again, guys, the purpose of my video is not to teach you Python, but rather to show you how you can use Python to do K-Mearn machine learning. So I'm typing the code in Python. So to really enjoy this video, you should know at least some basic in Python. So I will click Shift and Enter key on my keyboard to run this cell. And then the next step is to really selecting the feature of my data set and also converting it in a Numpy array. But the first thing that you can also do is to look at an example, the first row of your data set. So you can, for example, say df.head, Shift Enter, and you will see you have the first 5 rows of my data set. So you can see my data set has a 1, 2, 3, 4, 5, 6, 7 column. But I'm not going to use all of this column as a feature. So what I'm going to be doing is I'm going to be selecting a couple of two of them to set them as my feature and converting them in a Numpy array so that I can run my K-Mearn. All right. So to do that, what you have to do is basically I will type X. Okay, this is the name of my feature, and I will set the feature, and then I will choose build length and flipper length as the variable from my data set for which I want to run the K-Mearn. So I will type X, and by convention it's uppercase X. So I say X equal NP. I'm calling the Numpy library dot as a array, and I will set which variable. The variable that I want is from my dataset df, open bracket. Sorry, I have to do it again for you. bracket, double bracket, and then I will select build length. I need to type it exactly how it is. All right, and then comma, quote, flipper length in millimeter. So you see that I choose these two variables to do my Numpy array. And one thing that I wanted to let you know is that here it is very important to note that one transformation is to you may need to do is often is to normalize it. But here I'm normalize it because you can see both build length and flipper length are in millimeters. So that means they are in the same scale. But if they are not in the same scale, it is a good practice to put all the variables that you will set as a feature in the same scale. But because I'm in both of my build length and flipper length are in the same scale, that means in millimeter, I don't need to do that step. All right, I wanted to stress that for you, that it is very important to normalize it, and we can do, I will do another video to show you how you can normalize your data set. So now that I'm done with that, by selecting the features and converting it into Numpy array, I just press Shift Enter, and we will start computing the inertia for each number of cluster using the for loop in Python. Okay, for computing the inertia for each number of cluster, the first thing that I will do is that I will create a variable which I will call Inertia, which is an empty list. Okay, and this empty list will be used to append the inertia that I will compute for each number of cluster. So, and then now I'm going to be using a for loop, and the for loop is really important because it allows you for iterating over a sequence. So that means it will allow you to repeat a block of code. And in my case, it will repeat the computation of my K-mean and my inertia and feeding my x that I define as an array for each level of k, and it will compute the inertia. So let's start by doing that. So I will say for a in range 1 to 11. So what this line of code is telling me is that for every value in a range from 1 to 10, 11 doesn't count. The second value should be +1. Okay, and I will call it a. Its value in that range is called a. What I want to do, I want to create an instance of K-mean. Okay, so I will call the K-mean algorithm K-means. Okay, and I want to do a cluster. All right, so I want to have an instance of each K-mean with a value of from 1 to 10. So I will say the parameter is n underscore clusters equal to what? To the a. Okay, right? Okay, and I can call this cluster. All right. So once I'm done by creating an instance of K-mean, I will fit this K-mean to my x. So I will basically say cluster, okay, dot fit what? Fit the x, okay. And the third finally is to compute the inertia for the different instance of K-Mearn with a K value ranging from 1 to 10. All right. So I'm going to call the inertia empty list. So I will say inertia dot append, meaning add. Okay. And what I want to do, I want to call the cluster dot, and I will calculate the inertia. I will ask some K-Mearn to calculate the inertia for me. Inertia. All right. And basically, I am done. All right. And the next thing that I need to do is to create a list of K from ranging from 1 to 10. So it will be K equal list parentheses range 1 to 11. All right. So now I can plot the inertia for each K ranging from 1 to 11. So I will use the Seaborn. So remember, I call Seaborn as SNS. So what I will do is I will say SNS dot line plot, and I want to put in the x-axis the K, comma, and in y-axis I want to put the inertia that I just appended from my for loop. And after that, I just need to plot this line plot. I will say plt.show, and I will basically click or press the shift enter on my keyboard. All right, it says that I have a mistake, as I said clutter, okay, in that line 5. I go to line 5. Effectively, you see that I put clusters and S, and I missed the S here, and it did not recognize it. I finish and I correct it, and it should be generating the plot for me. It takes a little bit of time, depending on how many, and it should be plotting it for me. Here we go. All right. So now we have in the x-axis the number of K, and for each number of cluster, it has generated the inertia. For example, for inertia of 1, probably here you have over the 70,000 in terms of inertia. So when I go down, I can see probably my inertia is between 3 and 4, but I will, in that case, I will choose 3 because it is really where I can see not a big difference in terms of decreasing of inertia. So 3 will be the inertia, the level of K that provide me the trade-off between the number of K and the level of inertia. So 3 will be the number optimum of K. I can also, if you want, I can also print this this inertia for you. So let's see, and we'll do print, and because it's called inertia, it's a list. So I will say inertia, and it will give me. So this is the different value of inertia. All right. One thing also that we can also do is that sometimes it's not so obvious from the chart where you can get this inertia. So there is a method called need locators that allows you to really, from the inertia chart, to locate the number of inertia. So let me just plug it for you. So I will have to import it, a new for you. Okay, so the first line is that I am importing the KNI locator from the KNI, and then I will use the KNI locator here, and I run the same range, and I want to do it the inertia and the convex, because this is a format convex, and I want the direction to be decreasing, and the key, and I will type KL dot elbow, and it will tell me exactly which one it is. It is between the 2 and the 3, but I guess it's the 3. Let's see how it says. Okay, so it says it's 2. So effectively 2 is the optimum number of clusters. So I was wrong. It has identified the elbow here as a 2. So the number of clusters that will provide the optimum value is 2. Okay, now that I found the optimum number of cluster, which is 2 apparently, and I was able to see it see it in my chart. It's between 2 and 4, but I used the KNI locator to find it, and KNI locator told me that it's 2. So let's run a K-Mearn with this optimum number. So basically what we need to do is to again do clustering equal, again we're going to create an instance of K-Mearn with number of cluster equal to 2, so we can K-means, and the hyperparameter that we want to use is n number of n clusters equal to 2. We set it as 2 now because we have found this is the optimum number, and then we will fit it to our array here, where we have bill length and flipper length. So we'll go and we'll say clustering equal, okay, not equal, we're going to fit, okay, and fit to what? To x, and shift enter. All right, so it has created an instance for us. So now we can also, if you want, we can assign from each row in our data set, we can assign the cluster. So let's do that. Let me create an empty space for us to create the code below. And basically what we need to do is we're going to call the df, okay, and we're going to call the new variable quote cluster, okay, and what we're going to do, we're going to call clustering, okay, and we're going to assign the labels, underscore, all right, shift enter, it works. And then if you want to see an example of the 5 row, how it has been assigned, just type df dot head and shift enter. All right, so you can see that he has created. It says the first row is belong to cluster 1. Or if you want to see the whole thing, so let's just remove and just, right? So you see it has created. Yeah, for example, this row is belong to the cluster 0, right? Okay, now that I have assigned to each of my row in the dataset to a cluster, that means each row in my dataset has been assigned to a cluster either 1 or 0. I can also visualize this, and I can also do a plot where I show my scatter plot without clustering and my scatter plot with the clustering. And I already did that, and I'm just plugging the codes for you, and I will go quickly and explaining you how it works. So So now what I did basically is in the first row, in the first line of code, I set a subplot where I have a row, one row, and I have two columns. And the first column will be where I will be putting the scatter plot without clustering, and the second column will be with the clustering, and the size will be 15 by 5. The second line of code is for the first chart without clustering, and I said here it will be in the axis 0, and it will be the data. The data that I want is the df, and it will be the build length and the flipper length, and I set the title as without clustering. The second, the third line of code will be for my scatterplot with cluster, and again it will be axis 1, and I will be using the df, which is this df here, and I will be using x build length, while y flipper length, and the hue will be the cluster variable here that I choose, and I set the title as with cluster. So when I'm done with this code, I will just click Shift Enter, and it will generate this nice two charts for me. That one is a cluster without the scatter plot without the clustering, and that one is the chart with the optimum number of cluster, which was 2, that I calculated at here for you. Thank you for watching this video, and I hope that this was very useful for you. Also guys, I will be attaching in the comment section of this video a link where you can have access to all of this code that I just show you how to do clustering using K-Mearn and the elbow method. If you like this video, give me a thumbs up, and also don't forget to click on the subscribe button below so you can be informed when I'm releasing a new video around thematics such as Python, machine learning, Excel, Power BI. Also, I just wanted to finish this video to tell you that all of these things that we just did in Python using this IDE, we can also do it in Power BI. And I will be releasing soon a video on how you can do all of this machine learning stuff, specifically in K-Mearn on Power BI. Stay tuned, and again, don't forget to subscribe to my channel so you can be informed when I'm releasing a new video. Take care, and happy 2023 New Year's. Ciao.